Hello, everybody. Welcome to robotics class. I can't believe this is week 26. Gosh, I just can't deal with time. I'm sorry. I don't like when it seems like everything is just disappearing and you guys are just growing up so fast. I just want, I don't know, I just want to make the most of our time every week. And so hopefully you guys are doing well. And so we're going to continue. We're in unit 5 now. So if you remember, we started out learning about the distance sensor, right? And we were in the same maze, except different sensor. So we're learning how it works. And like, I think I might have brought this up last week, but just to kind of review, robots, they need sensors, right, to give them the ability, right, to gather data and know how to make decisions. So it helps them to get intelligence, right? And so if you remember back to the beginning of the year, we learned about the characteristics that robots need, right, in order to make them a robot. And they need sensing and they need intelligence, right? And they need energy and they need movement. And so we're really focusing a lot on the sensing right now and the intelligence, because that's where the code gives the robot the intelligence and the sensors give it the information that it can use to make an intelligent decision, right? So it is really crazy when you think about it, how robots, like they're really the people working on them, they're trying to think, how can we create these machines that can think and make decisions, right? And it's just so wild when you stop and think about it, just the whole field of robotics and like the things that robots are capable of doing, right? And I know we watched those documentaries at the beginning of the year, and it really is, if even since now, from back a couple of months ago, there's been so many new robots that have come out. I don't know if any of you guys followed the news about robots, but I mean, it's just crazy how quickly and this field is emerging and new things are coming out. So if you ever just want to follow, it would be interesting, to keep up with the news on robotics and see all of the things that these tech companies are working on and how they're really going to be changing our future. It'll be an interesting world with robots, right? Ooh, excuse me. So lesson 2, we're using comparison blocks and driving until near. So in this lesson, we're going to create a project where the VR robot navigates to the letter A using the distance sensor. And then after that, we're going to do a mini challenge where the robot goes to the number 1. So we'll be learning. So remember, here's our maze. So we'll be getting the robot to the letter A, and then we'll be getting the robot to the number 1. And actually the code you'll be sending me is the robot to the number 1. But we'll show you the code to get to A as well. So we're going to be using those Boolean blocks. So if you remember, those blocks report back a true or false value, right? And that helps the robot to make a decision of whether or not to move and what to do in the maze. So we'll be looking at a lot of these blocks. So you could start a new project, but actually, let's not do that yet. So let's just follow along. So we're going to be using our drive forward block. We're going to be getting a wait until block. So these are all pretty standard blocks. We've been using them every week. But we're going to be using the distance from block inside of the less than Boolean block in this project. And we'll be learning about the less than, the greater than, and the equal to comparison blocks. So some examples here. So if you notice, the less than block will report true when the first value is smaller than the second value. And then it will report false when the first value is greater or equal to the second value. So that's how the less than works. And then the greater than is the reverse. The greater than will report true when the first value is larger than the second value. And it will be false when the first value is smaller or equal to the second value. And then what do you think the equal to does? It'll be true when the values are exactly the same and false when they're not. So these are pretty standard, I think, hopefully not too complicated to understand. So comparison blocks can accept decimals, integers, numeric blocks. So anything with a number, you cannot put in a word. They can also accept round reporter blocks, such as the distance from block, which we'll be using, right? And you remember you can do distance from, you can use millimeters. So in this example, if you take a look, distance in millimeters, it says that it will report true when the distance from an object and the distance center is less than 50 millimeters. So when it's less than 50 millimeters, it will report true. And so here we go. They're adding some code here. And so it says, wait until the distance in millimeters is less than 50. And then the project will move on to the next block in the stack, which in this example, they're putting the stop driving block. So a stop driving block is needed after the wait until block because the VR robot will just continue driving until it's instructed to stop. So we do have to put that stop block there. A stop driving block is needed after the wait until block. And so we already see it there. So there we go. We have we're putting our code together. And so if we watch this inside of the maze, we will notice that it will just start driving and then it will stop when it hits the wall, right? So that's basically the basic code. I think we did something similar last week, just learning how to use it. Okay, so let's move on. Now we're going to try to get the code to get our robot to the letter A. So now that we created and tested it and we know how it works, we can try to get through the maze, right? So to drive to the letter A, our VR robot needs to detect two walls. So hopefully everybody can see this. So we're detecting this wall right here, and then we're detecting this wall right here. So we have to think about that. And it also needs to turn left when these walls are detected, because we can tell it's going to drive forward, it's going to turn left, it's going to drive forward, and then it's going to turn left again, and then it's going to get to the A. And then it needs to stop when it detects the third wall, because that's the letter A, right? So we'll be thinking about it. So we'll be thinking about the code. So we have when started, drive forward, wait until the distance in millimeters is less than 50, then turn left for 90 degrees. So we're going to be adding another block in here. We're repeating it because we're going to be doing it 2 times. So you can always use the duplicate block. And then finally, we will add the last block, which is our stop drive block. So this would be the code to get to the letter A. And so then we would launch our maze, and then we would test it out, and then we would see our robot getting to the letter A. And so hopefully this code makes sense to you. It's basically a repetitive pattern. So when we have a pattern, it's pretty easy because you really only need to do the code once and then you can duplicate it. Drive forward, wait until the distance in millimeters is less than 50, turn left for 90 degrees, drive forward, wait until the distance in millimeters is less than 50 degrees, turn left for 90 degrees, drive forward, wait until the distance in millimeters is less than 50, and then stop driving. And if when you read this, hopefully the code is starting to make sense, because when you read this and you look at the maze, it's almost like as though you could write this down, as almost like a step-by-step, right? You could you know what you're doing. You're driving forward, right? You're waiting until the drive sensor records a value that's less than 50, and then you're turning left 90 degrees, and then you're doing it again, and then you're doing it again, except this time you're stopping when you hit the wall because there's nowhere else to go, right? So hopefully you're seeing the repetitive pattern here that we're using. So now we're going to go to our challenge that we're going to be doing this week. So in the mini challenge, we're going to try to get the robot to the number 1. So let's try and take a look if it actually maps this out for you. But we see how many walls are we dealing with. So we have one wall here, another wall here, another wall here, and another wall here. So it looks like we have about 4 walls that we're dealing with. And why are we looking for those walls? Because we know that we need the distance sensor to be able to measure how far. And so when it gets close enough, it knows it needs to turn, because if it doesn't, it's going to crash into the wall and then it will be stuck. So that's what we're really trying to figure out. So if you look here, I'll show you guys this video really quick. Why don't you take a look? This is what we wanted to do. So you see it turning straight, it hits the wall, it goes forward, it uses the sensor and hits the wall, it turns, hits the wall again, turns, and then it gets to the number 1. So that's pretty much what we're trying to accomplish here. So we're going to go into a new project. And so this one has already, I already named it, but you can just put your name. So you would put your name, Unit 5, Lesson 2. You could call it Mini Challenge. You could also call it Get to Number 1, whatever you want to do. Mini Challenge, Get to Number 1. So let's think about the code here. I already actually plugged in some code, but we can have you guys try and follow along. So let's try and see here what we're going to be using. I'm just trying to see if I can make it a little bit bigger. So we know what our goal is. We want to get to the number 1, and we're trying to figure out how we can do that. So I'm just trying to think if I want to mention anything else. I think I mentioned everything in there. Okay, so we're starting out, and let me open up the playground. So we're starting out in our regular starting spot here. And so now if we take a look, the robot is currently facing in a direction that we can't just drive forward right away, right? We need to turn right by 90 degrees to get ourselves. So our first block is drive right for 90 degrees, and then we can drive forward because our robot is not in the correct direction. I hate that this thing is so down. I know you guys probably have a hard time seeing it because it's here and it's facing up, but we need it to face this way. So we have to turn right and get the robot to face in the correct direction. And then we can drive forward. So in this case, we're going to be waiting until the distance in millimeters is less than 35. So this is what they've chose to use for the distance sensor. So you would put that in, and then as soon as the distance is less than 35, we're going to turn left 90 degrees. Why are we turning left? Because we can see that we're going to hit this wall and we want to go this way now. So then we're going to do that. And then we're going to turn right for 90 degrees and drive forward. And then same thing. So we're doing it 4 times, right? Because we had 4 walls. Turning right for 90 degrees, driving forward. And then with our last wall, we wait until the distance is less than 35 and then we stop driving. So if I do this, it should get me to the number 1. So there's our robot turning, coming up, hitting the wall, going straight, turning, driving forward, and turning and getting to the number 1. So I hope everybody could see that. I'll bring it up a little bit, but you see it got to the number 1. And so that's really the goal here. So it's not too complicated. What you can always do is if you get your code set up, you can copy if you want to duplicate, but you have to be careful with the directions because you have a turn right you're starting with, a turn left, and then you have a turn right and a turn right. So you want to make sure that you don't mess that up, the directions. Directions are very important when you're working with robotics because if you go in the wrong direction, you're not going to get into the maze correctly. So again, you're looking at the maze, you're like, oh, I need to turn right, then I need to turn left, then I need to turn right, and then I need to turn right again, and then I need to turn right again. So you kind of have to visualize it when you're looking at it. And this is where you really have to kind of just use your brain to visualize the directions. And it can sometimes it gets people stumped a little bit because it could be like almost like a brain teaser or something. You have to really visualize yourself being the robot and then try to figure out which way you need to move, which way you need to turn to be correct in the correct direction to finish the maze. So that's what you guys are going to work on. this week is getting to the number 1. So the code is all here. I'll shrink it down so you can see it in one shot in case you're like pausing your video. Oh my God, that's really too small. What did I do? Well, if you have a magnifying glass. So yeah, anyways, here's the code. But as you can see, it's super repetitive. The only thing is we have a turn right, a turn left, a turn right, a turn right, a turn right. But everything else is exactly the same. And then we have our stop drive at the bottom. Okay, so then let's take a look at our quiz this week. And so remember, this is going to be part of your grade as well. So you do want to complete it. Okay, so let's take a look at the quiz. So which of the following blocks is a Boolean block that reports if the first value is larger than the second value? So is it the less than block, the greater than, the random block, or the and block? So that the first value is larger than the second value. So let's think about, what do you guys think for that one? So hopefully you're thinking greater than, right? Okay, for the next one, which of the following blocks is a Boolean block that reports if the first value is less than the second? Hopefully you're thinking the less than block. All right, for the next one, what value does a greater than block report while inside of a wait until block? So let's take a look at this. What do you guys think? What does it report? So it reports a true or false value, right? It doesn't report the distance to the nearest object or the total time the VR robot has to reach an object. It's a Boolean true or false, right? Which of the following describes that the VR robot will drive forward until the value of the distance sensor is less than 150 millimeters? Drive forward for 150 millimeters? No. Drive forward until the distance sensor is greater than 150 millimeters away from an object. Drive forward until the distance sensor is less than 150 millimeters away from an object. Or drive forward, stop, drive forward again for 150 millimeters. So hopefully you're thinking C until it's less than, right? And then let's look at this example. Why was the drive block used instead of the drive for block in this project? So when started drive forward, wait until the distance in millimeters is less than 150, and then stop driving. So if the drive for block was used, the VR robot would drive a specific distance and come to a stop before moving to the wait until block. And so this is why the drive for block is a waiting block and does not allow the project flow to continue until its condition is met. If the drive for block was used, the VR robot would start driving until it was told otherwise. This is because the drive for block is a non-waiting block and will allow the project to move to the next block. And so we know that's not true. It's not a non-waiting block. If the drive for block was used, the VR robot would drive for a specific distance 4 times, acting as a repeat block. If the drive for block was used, the VR robot would not move. This is because the drive for block is a reported block. So hopefully you're thinking number 1, because the drive for block is a waiting block, because you say drive for and you put like 3 seconds or whatever. But we're just using the drive forward block because we wanted to keep moving with the blocks in order to do each of the steps. So it was A. So that's your quiz for this week. And then make sure to create the code here to get to the number 1 and then send it to me. And that's your assignment this week. Okay, guys, have a good week. I'll see you. Bye.